喂，咁多位大家好，我係梁 Sir。連續呢3段片咧，我哋都會去揾一揾基礎遺傳學 （Basic Genetics） 嘅。咁我哋研究下呢個個案啦。咁啊，有一款植物咧，我哋有以下嘅交配嘅結果嘅。咁呢款植物咧就好特別嘅，佢有分男性植物同埋女性植物嘅。佢一係咧就淨係得雄性嘅花，就得雄蕊啦；一係咧開得嘅花咧都係雌性嘅花，就淨係得雌蕊嘅。咁題目咧都提咗我哋啦，呢一棵植物嘅花嘅顏色咧係受到單一嘅基因咧所控制住嘅。咁即係平時我哋嘅 monohybrid 單基因雜種遺傳啦，係咪？咁以下咧我哋有5個嘅雜交嘅結果啦。咁啊雄性嘅親代啦，紅花定白花啦；雌性嘅親代啦，係白花定紅花啦；生出嚟嘅後代啦，究竟紅花定係白花啦？咁啊例如啦，第一個係雜交啦，雄性嘅白色花同雌性嘅白色花做完個全花粉啊，做完個受精之後咧，咁啊生出嚟啦，咁啊全部嘅後代咧都係白色花嚟嘅。咁啊不厭其煩提一提大家先啦，做呢類型嘅題目咧，一定要識得揀一個正確嘅雜交去睇嘅。如果唔係嘅就嘥咗自己啲時間，亦都未必得出一個正確嘅答案啦。咁啊講條題目之前咧，原來都仲有一個資訊咧，題目想講嘅就係呢一棵植物嘅性別決定咧，原來係同人咧係相似嘅。咩意思咧？人嚟講 double X 係嘛，有2個 X 嘅染色體咧就係雌性。如果啦佢有個 Y 嘅染色體就係雄性。咁而家入題目咯喎，根據翻以上嘅雜交嘅結果啦，咁以下邊一個嘅配對咧係能夠正確咁描述到開白色花嘅等位基因究竟係顯性定係隱性啊？呢個等位基因嘅位置究竟佢係喺 autosome 體染色體啊，定係 sex chromosome 性染色體咧？邊個配對係正確嘅咧？咁呢個題目咧就考翻我哋啦，有關於性連鎖遺傳嘅概念啦，同埋啦想我哋分得清究竟咧一個等位基因佢係喺體染色體同埋性連鎖，即係喺性染色體嘅時候啦，究竟出到嚟有啲咩嘅特性，有啲咩唔同咧？咁啱啱咧都提咗大家啦，要揀一個啱用嘅雜交，咁先可以做到條題目噶嘛，係咪？咁其實1咧我係唔會考慮嘅，因為1咧就係白花溝白花，生翻出嚟全部得白花，其實冇乜嘢好睇嘅。因為我想分得清究竟紅花白花究竟係隱性定係顯性啊嘛。咁即係話啦，阿2同阿3咧係啱用嘅。咁陣間咧我淨係用2號呢個 cross 嘅啫。咁啊3號用唔用得都用得嘅。咁但係啦，有陣時話做題目快啊嘛，係咪？2同3揀其中一個咧夠用有餘㗎啦。咁4號啦，用唔用得咧？咁你話喂，紅花溝白花生到有紅有白，咁喂好正常啫。咁但係啦，但係呢條題目當中咧，我哋淨係揀咗阿2號係唔夠嘅，我哋要揀多一個做配對，咁我哋都會揀4號嘅，陣間就解釋俾大家聽啦。咁5號啦，喂有個問號嘅，我都未知係乜嘢，所以5號咧暫時我未用得嘅，喺第16條。OK，咁做呢條題目咧，我哋有2個思路嘅。第一個思路咧就係去判斷翻究竟白色花嘅等位基因究竟係顯性定係隱性啦。而第二個思路咧就係判斷翻呢一個白色花嘅等位基因究竟佢係咪性連鎖啦。好，咁而家我哋解決第一個思路先，我哋就用翻 cross two 啦。頭先我講咗2同3是但揀一個夠噶啦，我用2號嚟做個示範啦嚇。咁啊因為今次要解題啊嘛，咁所以就仔細啲嘅。咁但係其實實質咧要畫呢圖咧好快畫得晒嘅啫。咁第二個雜交咧我就先假定咗先啦。嗱，因為我唔知噶嘛，係咪啊？紅花白花係咪一個性連鎖啫？我扮唔知嘅啫。咁而家當啦如果佢咧佢係喺體染色體個樹，會係咩情況咧？雄性嘅紅色花，佢起碼有一個紅色花嘅等位基因，對不對？雌性嘅白色花，佢都起碼一定有一個白色花嘅等位基因，對不對？呢個技巧咧唔係陌生㗎，我哋喺無中生有嗰度學翻嚟嘅，就係話嗰隻生物有個咁樣特定嘅表現型，咁佢就一定起碼有一條係能夠顯示到嗰個表現型嘅等位基因，對不對？咁即係話總有一部分嘅第一代咧係能夠獲得紅色花嘅等位基因同埋白色花嘅等位基因，即係話佢哋一定係一個集合型嘅狀態。而根據第一代嘅表現型，結果話俾我哋聽，全部都係紅色。咁其實可唔可能啊？都可能㗎，就係因為紅色嘅等位基因，佢正正就係一個顯性嘅等位基因啦，係咪？咁由於今次解題啊嘛，咁我哋梗係要扮下嘢。喂，如果佢係性連鎖咁啊點先？咁啊又睇下啦喎，雄性嘅紅花，雌性嘅白花。咁雄性嘅紅花，佢呢個 X 染色體一定有一個紅色嘅等位基因啦，而雌性嘅白色花咧，佢起碼都應該有一個 X 嘅染色體係有白色嘅花嘅等位基因，對不對？起碼有一個，都係用翻無中生有嗰個概念去講，起碼有一個嘅啫。咁即係話啦，又係講緊有一部分嘅後代，佢都一定係有 X 嘅染色體，有紅色嘅等位基因，有 X 嘅染色體有一個白色嘅等位基因，對不對？起碼有一部分啦，係咪？我唔夠膽講全部啊，係咪？咁根據翻數據嘅結果啦，第一代嘅表現咧，喂，應該全部都係紅色嘅喎。嗱，咁我哋都係嗰句啦，我唔諗係咪性連鎖住？咁其實啦，因為你齋睇都知得到啦，一定有一個 X 嘅染色體有白色嘅等位基因，再能夠 Y 咁樣嘅結合噶嘛，係咪？我唔理佢住，我特登唔理嘅，總有啲後代係有 X 紅色等位基因同埋 X 白色等位基因，結合翻呢兩個嘅雜交嘅可能性咧，我哋都知得到啦。如果有一啲後代佢係又有紅色嘅等位基因，又有白色嘅等位基因嘅話，能夠顯現到嘅都係紅色。所以啦，紅色花咧就係一個顯性嘅特性，而白色花咧就係一個隱性嘅特性。咁所以啦 ，A、B 咧就已經可以 say goodbye 噶啦。咁而家我哋揸住呢個概念咧，就諗一諗思路二咯。咁思路二咧，我哋要揾多一個 cross 去做嘅，就係頭先我講嘅 cross 4啦。咁其實 cross 4有咩咁特別咧？你望一望點解我會揀2同4，唔係揀3同4？因為啦，2同4都係講緊雄性嘅花係紅色花，雌性嘅花係白色花，所以你要我揀2同3嘅話，我就會揀2，我唔會揀3，因為呢兩個有得比較。比較嘅咩啊？係個結果嘅比較。2號嘅雜交全部都係紅色花，4號嘅雜交有紅花有白花，真係可以比較一下咯。咁根據思路1啦，我已經知道啦，紅色花嘅等位基因咧係顯性，白色花嘅等位基因咧就係隱性。咁而家喺第4個嘅雜交入面啦，如果佢嘅等位基因係喺體染色體嗰處啦，會有咩情況咧？雄性嘅紅色花起碼有一個大階 R， 係唔係？咁雌性嘅白色花一定係 homozygous recessive 純合型嘅隱性，對不對？咁只係爭在啦，喂，梁 Sir， 你點知道呢一個一定係細階 R 嚟㗎？嗱，我係一定知道嘅，因為啦喺第4個交配當中咧，我哋係有白色嘅後代，白色嘅後代都係純合型嘅隱性，係咪？咁所以啦，喺一個咁樣嘅情況底下，我哋就會知得到咧，佢一定係有一個隱性嘅等位基因嚟自於阿媽，而另一個嘅隱性等位基因就係喺阿爸嗰度嚟啦。咁即係話呢一個一定係細階 R 咯。咁而家呢個情況底下啦，咁呢個情況底下啦，做唔做到有紅花白花先？做到啊，係咪？呢一個係可以接受嘅。然後啦，我哋擺翻去真正嘅 cross 2嚟做個理解咯。喂 ，cross 2同4咧，其實一樣噶嘛，係咪？咁我就望一望咯，可唔可能咧？雄性嘅紅色花起碼有一個大階 R， 對不對？咁跟住啦，就去到雌性嘅白色花就係細階 R， 對不對？咁而家啦喺 cross 2嘅第一代全部都係紅色，咁即係溝得出嚟咧，都應該係一個集合型嘅狀態。咁呢個情況我哋就會知得到，應該喺 cross 2咧，佢就係一個大階 R，homozygous dominant 純合顯性嘅狀態啦。咁根據翻思路 2A， 咁原來啦呢個等位基因咧係喺體染色體喎，可唔可能啊？係可能嘅，因為啦無論喺2又好4都好，都解到話嘅，對不對？跟住啦就去到 2B 咯喎，咁啊如果啦呢個等位基因咧係喺性染色體上面，咁又如何啊？咁又望一望咯喎 ，cross 4如果真係性連鎖的話啦，雄性嘅紅色，咁即係話佢有一個 X 嘅染色體，有一個大階 R 啦，跟住啦能夠 Y， 因為男性啊嘛，係咪？佢就能夠製造到兩類型嘅配置啦。而雌性嘅白色花咧，就必然係 X 細 R、X 細 R 啦，對不對？咁佢只能夠製造到一類型嘅配置啦，係咪？跟住啦，交配咗出嚟之後啦，有紅花可以啊，有白花可以啊。根據翻第4個結果咧，咦，都吻合嘅，呢邊係吻合嘅。然後啦，我哋就望一望，真係 cross 2嘅話，會係如何啊？因為 cross 2同 cross 4實質啦，都係雄性嘅紅色花同埋雌性嘅白色花， 如果呢個情況底下啦，即係話真嘅 cross 2同 cross 4根本係一模一樣，都係 x 大加 r 配個 y 同埋 x 細 r、x 細 r， 生出嚟嘅話啦，應該係有紅花同埋白花嘅。但係喺 cross 2，你記唔記得個結果係乜嘢？我只係見到全部都係紅色花，即係話，如果我今次係想用聖連鎖嘅角度去解釋嘅話咧，第二個 cross 我就解唔到話啦。咁即係話控制花嘅顏色嘅等位基因咧，就唔係喺勝驗色體啦，咁就係喺體驗色體，所以答案咧就係 C 咯。嗱，咁可能你會覺得咧，哇，梁 Sir 你用咗咁多時間去解呢一條，咁咪花咗好長時間咧？其實唔係嘅，因為當我做嘅時候咧，其實你真係要即刻篩走1同3，淨係揀2同4已經好夠，因為2同4就係有一模一樣嘅親系嘅配搭，但係佢哋生出嚟嘅後代嘅結果係有唔同啊嘛，所以2同4應該係最容易去引到你嘅注意力去揀佢哋嘅。然後啦，畫翻呢兩幅圖，其實就已經好快。嗱 ，Sexling 呢一 part 咧，我唔做係冇乜所謂嘅。我齋做呢一 part 其實已經有結果㗎啦，但係思路2咧，其實2A、2B 咧，你總要行一次嘅，咁你嘅概念會更加清晰咯。Hello student, I'm Mr. Liang. So in the following 3 videos, we are going to do the revision about the basic genetics. So we are going to study different results of some crosses in one type of the plants. So this type of plant is very special. It produces the individual either bearing male flower with stamens only, or the female flowers with the carpels only. And then the question also told us that the color of the flower is controlled by one single gene. That means it should be the monohybrid inheritance. So for the concept checking, this question is checking us the sex-linked inheritance and asks us to differentiate the autosomal and the sex-linked traits. And then we can see that there are 5 crosses in the table with the male parents, female parents, and the phenotype of the offspring. So for the question, before we talk about the options, there is one more pieces of information. The sex determination of this plant is similar to that of human beings. It means that what if the individual bears 2 X chromosomes, it is female. And then what if it bears 1 Y chromosome with XY, it is a male individual. So for the question, which of the following combination correctly describe the allele for the white flower in this plant? So the combination, first part is that is the white flower allele dominant or recessive? And the location of the allele, should it be on the autosome or on the sex chromosome? So before we talk about the thinking logic, one thing I would like to remind you when we are doing the basic genetics question, we need to choose a suitable cross for our thinking logic. For example, cross 1, I will never use it because for the white flower cross with the white flower, there will be all offspring with the white flower. So it's nothing special, right? I really don't use it. And then for cross 2 and 3, red flower cross with white flower, and then all red flower in the offspring. White flower with the red flower, also all red flowers in the offspring. And then also number 4, it seems like very normal, red flower cross with the white flower, and then in the offspring, there are red and white flower. However, we still need to use it in this question. And for number 5, for question 16, we shall not use it first, but we shall use it later. And then for the cross 2 and 3, in this question, I will choose cross 2 for me to do the deduction. Cross 3, I won't use it, and then later on you will know the reason. Say, for this question, there are 2 thinking logic. Thinking logic 1, it helps us to determine for the white flower allele, is it dominant or recessive? And for the thinking logic 2, it helps us to determine whether the white flower allele is it sex-linked or not. So let's go through the thinking logic number 1. So for the thinking logic number 1, I will choose cross 2. Later on, you will know the reason. So for the cross 2, I pretend that I don't know whether the allele is it on the autosome or is it on the sex chromosome. So I will do it twice to present you to demonstrate how I think. So for the parents, male red flower. So for the male parent, it has at least 1 red flower allele, right? And for the female white parents, it has at least 1 white flower allele. So this at least one allele idea, we learn it from the out of nothing thinking logic, right? In the basic genetics. Therefore, what is the counterpart allele? I don't care. I just know that they at least have one red flower allele or white flower allele. And I'm sure that there must be some offspring, not all, maybe just some of them receive the red flower allele from the male parent and receive the white flower allele from the female parent. And then these some offspring, they must be heterozygous. And then from the result, we know that in the cross 2, all the offspring, they are red flower. Is it possible? Absolutely, it's possible. Because for the red flower allele, it is dominant. And then for the white flower allele, it is recessive. But you may think that, oh, no, Mr. Leung, is it possible for it to be sex-linked? Maybe, because I'm not sure at this moment, right? So I also do this for you. So for the male red parent, X chromosome with the red allele, and then with the Y, female right, that means X chromosome with the white flower allele. So I can say that some offspring, they may receive X chromosome with the red flower allele, and some of them may receive X chromosome with the white flower allele. So in this case, all the offspring, they are also red. Is it also possible? Is still possible because X chromosome with the red flower allele, the red flower allele is also dominant, right? So you may think that, no, Mr. Leung, there must be some other situation. For example, this X white with this Y chromosome, is it possible? Yes, but I just ignore them. I don't know. I don't want to know as well. I just want to know that what if the red allele and the right allele, they come together, which allele can be expressed? And I know that the red allele can be expressed. Therefore, from the thinking logic 1, we know that the red flower allele, it is dominant, and for the white flower allele, it is recessive. Therefore, A, B, say goodbye. And then we use this concept, and then we can think about thinking logic number 2. And for the thinking logic number 2, it helps us to determine whether the allele is sex-linked or not. So there are 2 branches. First branch is thinking logic 2A. What if it is autosome? Thinking logic 2B. What if it is sex-linked? So now I will choose one more cross to help me to deduce all the things. So I will choose cross 4. You may think that, why Mr. Leung, why you choose cross 4 but not choose maybe cross 3? So I can tell you that. Just take a look at the result. For the result, cross number 2, cross number 4, any similarity? The similarity is that for the male plants, both of them, they are red flower. And for the female plant, both of them, they are the white flower. It is the similarity. However, for the result is different. For the cross 2, all red flower in the offspring. But for the cross 4, some red flower, some white flower in the offspring. So therefore, we are going to compare the result of the cross 2 and cross 4. It can help us to deduce whether the white color flower allele on the autosome or on the sex chromosome. So from the thinking logic number 1, I know that for the red flower allele, it is dominant, so I use the capital letter R. And for the white flower allele, it is recessive, so I use the small letter R. So for the cross 4, what if it is autosome? So for the male red, it has at least one capital letter R. And for the female white parent, because the white flower is the recessive characteristic, so it must be homozygous recessive. So for this case, you may think that, oh, Mr. Leung, how can you say that it is small r? I show you why. Because from the result of the cross 4, there are white flower offspring, so they must be homozygous recessive as well. So it means that they receive one recessive allele from mother and one recessive allele from father. Therefore, this male red parent it must be heterozygous. For the result, is it really some red and some white flower? Yes. If I use the auto-sum concept, try to explain it, it's okay. And then I use this result to compare with the cross 2. So why I say it is the true cross 2? Because in thinking logic number 1, I do not use the big R or small r for the deduction, right? I just say that red or right. So for the cross 2, male red with at least one capital letter R. And for the female right, it must be homozygous recessive. So I know that, for the cross 2, all the offspring, they are red. So it's just like for the test cross. For the counterpart allele, it must be the big R as well. So for the male red parent, it is homozygous dominant. So is it reasonable to explain the result in cross 2? Is also possible. So the white flower allele, it seems like on the autosum. So let's think about the thinking logic 2b. So in this case, so in cross 4, what if it is sex link? For the male red, so it must be X big R with the Y. And then for the female white, it must be X small r, X small r. Therefore, we can see that 2 types of gamete produced by the male parent and only 1 type of gamete produced by the female parents. For the X big R, X small r, female red, and then X small r with the Y, it is male right. So from this genetic diagram, I can still see that some red, some white. So is it possible? Yes, it is possible. However, when we take a look at the cross 2, as what I say that why I choose cross 2, not cross 3, because from the phenotype of the parents, cross 2 and cross 4, they are the same. Male red, and then with the X big R, Y, female white, X small r, X small r. So you can see that if sex link is really the case, so I should have the same parents in cross 4 and cross 2. And finally, I can still get female red and male right. But the idea is that for the cross 2, oh my god, but for the cross 2, remember the result, all offspring, they are red. So can we use the sex linkage concept to explain the cross 2? No. Therefore, the location of the allele, it should be on the autosum, but not on the sex chromosome. Therefore, the answer will be C. So you may think that, wow, Mr. Leung, you used such a long period of time to explain this question because I was explaining the questions. Therefore, I need to explain you step by step to guide your thinking logic. When I was really doing this question, I eliminate cross 1 and cross 3. And I just pick up 2 and 4 because the parent combination is the same, but we get different result. So these 2 crosses are the key.